This video shows us how to use the chain rule in differentiation. We use the chain rule if we have an expression to a power. So we've got an expression and then we've got an exponent. And the easiest way to explain chain rule is to actually just show an example. So that's what I'll do right now. So in this case, I'm given y equals 3x plus 5 to the power of 4, and I want to find dy dx. Okay, so how do I recognize that it's chain rule? Well, I've got an expression inside in brackets here, and I've got a power on that expression. So how do I differentiate? Well, the first thing that I do is I treat this bracket like it's one piece of information, almost like an x. And I use the exponent to differentiate as I would in the case of x to the power of 4. So I bring my power in front and then take 1 away from the power. That's the first step of this differentiation. So I've brought the power in front and I've reduced the power by 1. But I'm not finished yet, because I also have to differentiate what is inside in the bracket. So I must differentiate 3x plus 5 and multiply my result onto the end of my dy dx. When I differentiate this, I get 3, because 3x plus 5 differentiates to give me 3. And now I might like to do a little bit of tidying up. If I want to tidy up the result of a chain rule, the best way to go about it is take whatever's out in front, take whatever's out at the end, multiply those together, but in general, we won't expand the bracket to a power. So I'll multiply 4 by 3, I'll get a result of 12, I'll put that in front, and then I'll put 3x plus 5 to the power of 3 next to it. And that's my differentiation completed. So let's look at a second example. Okay, so y equals 4x squared minus 2x to the power of 5, find dy dx. First of all, how do I recognize that this is chain rule? Well, I can see that I've got an expression in a bracket to a power, an expression to an exponent, and that's the key to using chain rule in algebra. Okay, so just like before, I'm going to take my power down in front and I'll reduce the power by 1. Don't forget, I'm not finished yet, because I still have to differentiate what I have in the bracket. So this time I'll differentiate that and I'll get 8x minus 2. If I want to tidy up a little bit at the end, I can multiply what's out in front by what's at the end. Notice that this time it's more than just a number, so I'm keeping it in a bracket. And I put the 4x squared minus 2x to the 4 bracket at the end of that expression. Okay, here's one more example. This one's a little bit less obvious because I don't on first glance see a bracket and I don't at first glance see an exponent on my entire expression. But remember that a square root is just that. So if you see an expression y is equal to with a square root and there's anything more than just an x underneath there, then you're going to have to use chain rule. And the first thing you're going to have to do is just rewrite that initial expression so that you're showing that exponent to the half. Because of course a square root is just a power of a half. So now, okay, it looks an awful lot more like our chain rule examples from before now, doesn't it? I've got a bracket, I've got a power. Okay, so let's take a second to figure out what should happen. I want to bring the power in front and I want to reduce the power by 1. So dy dx will start off half x squared minus 4 to the power of minus a half. But again, be careful, you're not finished yet. You still have to differentiate whatever's inside in this bracket here. And that'll get multiplied on the end. So this time when I differentiate x squared minus 4, I'm going to get 2x. Okay, so now I can do a bit of tidying up here. So again, if I'm multiplying, I'll multiply the first by the last part. In this case, that'll just give me x, and I leave my bracket alone. Again, like I've been saying previously, if you're just being asked to differentiate, your differentiation is done at this stage. However, this is a good opportunity to practice your indices. Indices are all over the place in our course, and so we should take a chance when we get it to actually practice using them. So how am I going to be able to write this back in root form again? Well, first of all, we have that x out in front. Now that x has no power on it. It certainly doesn't have a power of minus a half on it. So I'm just going to leave that alone as it is. Now this bracket has a negative power on it. That means it's going to get sent into the denominator. So I'm going to say 1 over, and then it's a power of a half, so it's a square root. So square root x squared minus 4. And I could tidy this up a little bit further by just multiplying the x by the 1 and writing that as x over the square root of x squared minus 4. Remember though that this is only strictly necessary if they ask you to give your final answer in a particular format, or possibly if you need to use this derivative to go on and do something else in the question.